Alright, so I'm going to show you how to find the oxidation number of something, and you're going to need the oxidation number to go forth with bonding and figure out how these atoms are going to bond. So let's start with, let's just pick magnesium. We'll back up. First, let's go back to valence electrons. I showed you a pattern with valence electrons the last unit, or the unit before last. What was that pattern? How many valence electrons are in this column? One. How many are in this one? Two. We're going to skip that dip and go 3, 4, 5, 6, 7, 8. Right? With the exception of helium. Helium's 2. Alright. So let's just pick magnesium. How many valence electrons does magnesium have? 2. It has 12 total electrons. So let's draw out this Bohr diagram real quick. Let's go to magnesium. So I've got magnesium. It has 12 protons, 12 neutrons, and 12 electrons. So how many electrons go in that first level? 2. How many electrons go in that second level? 8. 1, 2, 3, 4, 5, 6, 7, 8. Alright, so that I used 2 plus 8. I've used 10 electrons. I had 12 total to start with. How many do I have left? 2. I have 2 electrons. So where are they going to go? They're going to go on the next level. Now you always need to keep in mind 8 is the happy number. Okay? 1, 2. Because even as those levels get bigger and hold more, there's sub-levels within. So, but I want you to always think of 8 as a happy number. 8 makes the atom happy, okay? All right, so we've got 2 valence electrons. Now, I've got 2 options to be happy if I'm magnesium. My 2 options are I can gain 6 more electrons. 1, 2, 3, 4, 5, 6. I can gain 6 more electrons to give me 8. Or I can lose these 2 electrons. That takes all of them off of this outer level. Now do I have a full outer level if I've lost those 2?
Yes.
Yes, okay. Well, let's go a little bit further. All right. All right, this is where I'm going to get you going, okay? We're going to both Germanic so that we're COVID friendly here. All right, I've got 8 expo markers. I want you to think of these expo markers as electrons, okay? And I also want you to think of atoms and electrons as being very lazy, okay? Very lazy, like us on Thanksgiving, right? Very lazy, all right? So, I'm going to be magnesium. Actually, I'm going to let you be magnesium. So I'm going to give you, I've got 2, I know we can't see her on camera, but I've got 2 electrons. These are your valence electrons, okay? Now we've got 2 options for you to have a full level. You can either give me those 2, so hand them to me one at a time. 1, 2. All right, now she's lost those and she has a full outer level. Or, there's your 2 valence electrons. I can give her 6. So, 1, 2, 3, 4, 5, 6. Which was less work? For her to give 2. That was less exchanging, right? That was 2 times. Whereas if she gained 6, she had to bring in 6 times, right? So atoms are going to go with what's the least amount of work. So it was, for magnesium, the least amount of work is to lose 2. All right? With that in mind, let's go to a nonmetal. Okay, let's go back to our periodic table. Let's look at fluorine right here. How many valence electrons does fluorine have?
7.
It has 7 valence, all right? So you're going to start off with 7 valence electrons, all right? Is it easier to give me those 7, one at a time? 1, 2, 3, 4, 5, 6, 7, or I'll give you your 7 valence electrons to start off with. Is it easier for me just to give you 1?
Give her 1.
Well, it's easier. Just giving her 1, right? So she gained 1. All right, if she gained 1, what's her charge going to be? Positive or negative?
Negative.
Negative, because she gained negativity. She gained that electron. But if you give them away, you're losing that negativity. What's your charge going to be?
Positive.
Positive, okay? So that's how I want you to think of atoms and finding an oxidation number. Okay, so let's look at if I am selenium right here. What's my valence? How many valence electrons do I have?
6.
I have 6. Is it easier to gain 2 or lose 6? Gain 2. Why am I deciding gaining 2?
Because it's less than 6.
It's less than 6, but where did I pull that 2 from? Where did that number come from?
To make it 8.
To make it 8, to make it happy. Okay, that's what makes atoms happy, is they want 8 valence. So if I said for this one, for potassium, how many valence do I have?
1.
I have 1. Is it easier to lose that 1 or gain 7?
Lose 1.
It's easier to lose that 1. So what would my charge be if I lost?
Positive.
Positive. How many did I lose?
1.
1. So my charge would be positive 1. I know I'm adding a new step. Okay. Let's look at phosphorus. What's my valence electrons on phosphorus?
5.
5. So is it easier to lose 5 or gain 3?
Gain 3.
It's easier to gain 3. So if I gain, what's my charge going to be?
Positive.
Negative.
Negative.
Yeah,
Okay. If I gain, it's going to be a negative charge. How many did I gain?
3.
3. So my charge is negative 3.
What if it's like carbon? Doesn't matter.
Okay. So carbon is right here in this middle column. You've got 4. Is it easier to lose 4 or gain 4?
Neither.
Neither. A lot of times those elements are going to end up sharing, which will be in our next unit, covalent bonding. But you could go either way. So it would depend on if they lost or if they gained. Normally you're not going to see that. You're going to see a sharing. Let's look at aluminum. Aluminum's got how many valence?
3.
3. So is it easier to lose 3 or gain 5?
Lose 3.
Lose 3. So if I lose electrons, my charge is going to be
Positive.
positive. How many did I lose?
3.
3. So my oxidation number is plus 3. Does that make sense? Yes?